What's up, guys? I got good sleep last night, dude. I tell you what, as somebody who has sleeping problems, especially lately, since things have been going on in my personal life, um, it is so nice, dude, when you get a full night's rest. Like, I got a solid 7.5 hours. I don't think I woke up like one. I might have woke up like one time for like 2 minutes. Usually I wake up like 10 times for like, I don't know, 5 minutes. Usually you lose an hour just throughout the night after I fall asleep. But anyway, got good rest. So I am picking up where I left off yesterday. Of course, where else would I pick up? But anyway, we stopped at line 56 in change attribute list. We had began implementation, roughly 20% finished, of creating a finished outline for implementation of what? The apply order integrity issue. Determined to use 2 counters, 1 for each client, create a finished outline. Okay, 56 in change attribute list. So let's go to 56, and actually, I'll just put this right here because that's pretty much what we're working on. And continue implementation of player. And then I'll just put my little thing that I do, which is finished, question mark. Okay, so alright, stopped here. Okay, so it says I wrote that we need to change below to be C1, C2 apply counter. Need to create logic here to update one or both depending on whether or not adder name is game adder. Verified game adders do not need to be transferred in terms of other clients, so they will be filtered out of change attribute list. And then for other client send, after current client send. Yep. So we definitely, let me just make sure like we're on the right track here. So we're gonna have the C1, C2 apply counter, and those are gonna be imported. Those are gonna be imported into like what, pretty much everywhere. Well, yeah, like most files, anywhere where anywhere where data point change is made. But wait a second. Well, I mean, I could just create them here. Like, can I just create the now this is a little bit like, okay, I think about, at least for me as a relatively new programmer. So if I'm importing data transfer function, and data transfer function is going to be using the global C1 C2 apply counter, which is going to be created as a global variable in this file, change attribute list. If I want to access, well, I don't have to access. Okay, yeah, that's right. I don't actually have to access C1, C2 apply counter from the client because there's going to be their counter that just starts at 0, like, and goes up by 1, like what they expect. We can call it like the expect counter or something. And also I'll add that. I'll put expect counter. Now I'll tell you what, getting separated from my old desk and setup not being able to type right ever since. My desk is not the same. It's really it's really bad, actually, like really bad. Anyway, implement expect counter in client pi, and where else? It's like my keyboard is just not centered correctly. Implement expect counter in client, and well, we also need the expect counter in server as well, because we know on both sides. Okay. Yep. So we're good on that. Alright, now. So yeah, if we create the C1 and C2 apply counter here in this file as a global variable, we import this global variable just like we do with data. Well, this is going to actually replace the data change apply counter, and then we're going to import the data transfer function. The data transfer function is going to increment the counter each time, which right here is going to be replaced with C1 C2 counter, and then that's going to be dependent on like which ones get updated. It's gonna increment both of them if it's a non-game attribute. If it is a game attribute, it's going to be incremented, both of them, that is. And then if it's a game attribute, only one of the associated counter is going to be incremented. And after it's incremented, right in the same function, the data is going to be appended to the change attribute list through the cal lock list function, and that is going to include the oh wait, hold up. Wait a second. CL2. Okay, that's right. Yeah. We pass. Okay, so yeah, from the main thread, which is source of like the data change, we call this function. We pass in the change attribute list object, which is the associated change attribute list. We pass in the game object and the change attribute list tuple, which is the actual data. Well, and then okay, so basically what we'll have to do here is we're gonna add to the tuple, which we actually can't add to it. We'll just create a new tuple with those two values added to it. Remember, because we said we're gonna put the client 1 counter first and then C2 counter second, so that this cal tube is going to consist of all this right here. It's going to consist of the current time cal tube, C1 apply counter, C2. So we have to add the C1 and C2 apply counter here. Otherwise, whenever we did the data changes, like all throughout the project, we would have to increment the counters there, and that means we have to import the counters there. So if we just import this function, which is already imported, it just makes sense, you know, to do that in this function. Plus, I think this is just the logically proper place for it anyway. It's the most like sensible place for it to exist. Yeah. And then we're going to send the verified game matters NBC. So after all this is completed, we're going to I was just thinking about this section right here. If game object is not equal to none. So yeah, this part sets the game, the timestamps for whenever we make the data change. Right. Instead of doing it like line by line, we put it in this function. So yeah, after it runs this function, we make the data point change through this function. The counter is incremented here. The toop is updated. The toop is passed to cal lock list. The toop is added to the actual change attribute list. And then we go to, in the client thread, we detect the change attribute list as it is populated with all the tuples. We go to send it to the current client and also to the other client. When the current client receives it, they're going to receive it in terms of current client, which means they're going to look for the C1 apply counter, which is going to be the first of the two. Or actually, it's going to check the ID, and it's going to say, is this client 1? If it's client 1, it's going to grab the first counter. If it's client 2, it's going to grab the second counter. And those two counters are going to be different. Obviously, that's why I have 2. And if it's yeah, I'm just making sure like the counters are gonna be correct here, because if it's a non-game attribute, both counters are gonna be incremented. And then if it's a game attribute, only the associated one is going to be incremented. Yeah, so that should mean that the expect counter will equal the actual counter. So if P1 game makes a change, P2's counter is going to be 1 less, because it didn't get to send anything, so it's not expecting, well, rather, the next one that it receives is going to correctly be that second one or whatever. It's not going to be 1 off because we incremented the counter, you know, but didn't actually receive anything associated with that counter value. So every send, every tuple is going to be properly associated with an incremented by 1 counter value every time for each client, and I'm pretty positive it will work. I'm most certain. Yeah. Yep, I just like did the little thing in my mind. I did the little thing in my mind. You know the thing you do when you think about stuff and you like visualize it? Yeah, we're good. Okay, so, you know, it's always good to do that. Take your time. Make sure you mentally lay it out first. Don't just rush in and code it. Trust me, dude. Just trust me. Unless you're really, really just like high IQ, like whatever. Yeah. So Um, make sure my link works. Okay, looks like it works. I actually look rested. Like, I can see that I got rust in base on like how I look. I look more rested than I usually do. Okay, so let's do this. No more like up in the sky shit. No more talking. Let's implement this code. Need to change below to C1 and C2 apply counter. Alright, so let's go ahead and create. We'll do first things first. We're going to not have one anymore. We're going to have two. So we're going to call this the C1 apply counter. And then we're just going to, why is that capitalized? No. Caps lock. And now this is going to be the C2. Below, we'll call this below section now. And type int purpose counter that's going to be what's change. And I'll put we have two counters, one for each client. These counters will both be added to every data point change. On receiving side, will detect if client ID is equal to 1 or 2 and grab associated counter for data for perfect order data application. Alright, and I'll also add we need two of these because we don't send we don't send other game data. In game adder changes, only the associated P1 game equals C1. Only the associated counter is incremented because only that client will actually be sent that data change. We filter the changed attribute list immediately after current client send, and immediately, or not and, like immediately after current client send before other client send, removing those non-associated game adder changes. I know that's like a lot, but you know, hopefully I think that's a pretty good description, and I think it's worth putting there just if there's any confusion in the future, because there's certain parts of this code that I have almost completely forgotten like how it works, and I'm the only person who's ever worked on this project, so it is, you will forget some things. Okay, so now we have C1 C2 apply counter. That is a big step in the right direction, so we can get rid of this bad boy. Now we want to I'll just go ahead and do this part first. Creating logic here to update one or both depending on whether or not game adder name is game adder. So couldn't I basically just say if game object is equal to none, then increment both, otherwise, yeah, because that's how we do it. We already have this system in place, but for a different purpose. And see, we say if game object is not equal to none, that means add it to, and let me put this because like I'm not put this. Where's the div? Give me that div, boy. Give me that div, boy. Give me that div, boy. So say below section 6424. Oh, comment added. And let's see. Handles time tube. Handles time tube timestamp updating. Yes. If game object arg is equal to none, we aren't handling a time to. Ooh, almost got me there. Almost got me. I'm wrong. Not here, but in my assumption. Anyway, we aren't handling a time to adder. But that doesn't mean we're not handling a game attribute, because not all of the time tuple, not everything that's in the time tube is a game attribute. Oh, so I messed up yesterday too because I was looking at this list, but time tube is really like it's a different thing. So that's wrong. I can't actually do that. I can't actually go off of I already asked this before, but I can't remember. Is it faster to pass in? Is it faster to pass it in as an argument or to import it like directly? It's really like, you know, it's not critical. It's whatever. Okay. So game has an ID, right? Does game have ID? I don't think it actually does. It doesn't. Okay. So this actually, well, it's not misleading. It's fine. What we'll do is, well, okay. If I, fuck. So I can just create, like, so here's the deal. I need to be able to determine let me ask this real quick to GBT. I know it's scattered a bit, but this will die. Let's Python assigning or rather, will it take longer to check equality of a large class instance object compared to checking quality against a single digit integer? What? 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 No, oh, they're cutting me off of fucking chat jibbity. No. It will take longer to check quality of a large class instance object compared to checking quality against single digit integer. Ya bitches. They cut me off, bro. Chat jibbity. And Gemini is sleeping. Gemini, wake up, man. Hey, it's time. Let's go. Thank you. Damn. Yes, it will take longer to check the quality of a large class instance object. Yes, it will take longer to check the quality of a large class instance object compared to checking quality against a single digit integer. The reason for this is that comparing two large objects involves recursively checking the quality of all their attributes. Okay, so that is good for me to know because, oh, well, that's actually really a big performance flaw in my project then, where I'm like quite certain I check equality with objects because I just had this assumption that like you were just looking at the memory space. You were like, you weren't actually looking at the, you know, like you weren't looking at the whole thing. I was thinking basically it had like a little tag that was like the memory tag, and like it was just this memory string, whatever you call it, and that you were basically just comparing this memory string like against that memory string. But I mean, that's stupid actually, now that I think about it, like actually think about it, because well, like if you created a completely new object but it had exactly the same like attributes and all that, like everything was identical but it was a different object, like with a different namespace, like it was a separate, you know, like player 1 and then there's another player 2, but like technically the data within them is like exactly the same, would that find equality actually? In the provided code, the EQ method of the large class first checks if the other object is an instance of the same class. If it is, then it proceeds to compare the data attribute of both objects. In this case, the data attribute is a list. So the equality comparison would involve recursively checking the equality of each element in the list. On the other hand, comparing two integers is a simple operation that can be done in constant time. The benchmark code you provided confirms this expectation. The time, oh, so Gemini actually ran the tests. Look at this. Gemini ran the tests. I couldn't get, ChatGPT's like, no, I won't do that. I got it to do it. Like I tricked it into doing it. So I know it can do it. But anyway, The benchmark code you provided confirms this expectation. The time to check equality with the large class instance is around 16.21 microseconds, while the time to check equality with the integer is around 0.72 microseconds. Like, wow, that's like insane. Huge difference. This shows that this shows, what is a micro? A micro is a millionth, right? It's a thousandth. ChatGPT. This shows that comparing the large class instance takes significantly longer than comparing the integer. Yeah, cool. Thank you. Thank you. Thank you. And then you can share the code behind this result just to make sure it's not some bullshit. Okay, so EQ is like something it defined itself. Check quality. If not, is instance other large class. Return false. Return self.data equals equal to other data, which would just be returning true. Oh no, returning self.data is equal to other data. Oh, so data is just a list. Okay, I see. I get it. I was confused. Sorry, now result. And that is actually a very small object. There's like nothing. So it would be like way, like the actual results would be way more radically different. It would just be like 10 times longer. It'd be like 160 milliseconds versus like what, 4 milliseconds or whatever it was, 2, 3. Time for large object equals measure time. Lambda large object is equal to large object. I like how I did that. I like how it just said function. You pass a function. You normally don't think of passing in a function as an argument, but you know, that's pretty cool. And then you do end time equals time at time, return end time minus start time times. Okay, so it's thousandth. It's a millionth. Right, so a microsecond is a millionth. Okay. Microsecond is 1 millionth. I'm a little slow. Okay. Okay. So to be clear, in Python, if I check equality of 2 class instances, it will only return true if the class type is the same and every single attribute value is the same. Okay. Okay. I understand now. Okay, done. Cool. Uh, back to the code. So that's something I need to add to my things to do. It's not a pressing issue, but so let's put noticed that in some places in code I am comparing entire objects against one another when I could probably just compare the associated IDs. Comparing entire objects takes way longer than comparing two integers. Definitely a performance issue. Okay, yeah, so we'll fix that. And actually, the last thing I wanted to ask was about passing. I already asked this, but I don't remember. So we'll put Python. Does it take longer to pass merge class instance object than it does to pass a single integer? Python, passing a large class instance object to a function generally takes longer compared to passing a single digit integer. A large class instance can contain a significant amount of data in its attributes. Passing this data involves copying it to the functions of memory space. See, why did I feel like I got the opposite answer before? In contrast, a single digit integer is a small piece of data that can be copied very quickly. Reference versus value. In Python, integers are immutable and passed by value. This means a copy of the integer's data is passed to the function. Oh, wait a second. This means a copy of the integer's data is passed to the function. For large class instances, however, they are immutable and typically passed by reference. This means the function receives a reference memory address object, not a copy of the entire object's data. While passing by reference avoids copying the entire object, there's still overhead involved. Reference lookup. The function needs to look up the actual object data based on reference it receives. This lookup adds some overhead compared to directly accessing the integer value. For larger objects, even though the reference is passed, if the object has a lot of internal data, accessing its attributes within the function might involve further memory access, contributing to the overall time. It can become notable for very large class instances. Okay. I mean, I'm always like in favor of performance. I'm kind of like a performance freak. I like to perform well. So I think I will actually gonna make sure like to fix that. And so okay, and then okay, and the other thing that I was, what about passing an object as an argument versus importing that object to the file and referencing it via a global keyword. You need to explicitly pass the object every time you call the function, which can lead to some extra code. Reporting using global variable. Back up here. What? Did it just... Oh. Dumbass. I thought it didn't hit enter, I guess. Passing an object as argument to a function for form is better than importing the object and referencing it via a global variable. When you pass an object as an argument, Python typically passes a reference to the object that avoids copying the entire object's data for the function. Okay, so I just realized this, like, if I pass in a game object to a function, I don't have to actually reference, I don't actually have to import that object to the file where the function is created, because I'm importing that function where that object exists and passing it in. So when I modify the game object within the function, even though I don't actually that game object to the file where the function is created, I can still put in the code, at least I think I could put, let me test this. So there's a couple things I want to test to clear up any confusion I have, because, you know, this is just important. This is part of the process, unfortunately. I really want to finish this, but I need to understand how this works. So if I do, what was the first thing? The first thing I wanted to test was fuck, I can't remember. What was it, man? I wanted to test something. Yeah, I don't remember. I feel like, oh yeah, checking the equality of two instances. Right. Yeah, and I just wanted to I wanted to check that just to be sure. So let's create class CLS def init self. God, I wish I could type, man. So bad. Um, self dot x equals 1 and then self dot y equals 2. And now let's create C1 equals CLS and then C2 equals CLS. And then if C1 is equal to C2, print true. It didn't work? Did it timed out waiting for launcher to connect? Why?